In this video, we're going to look at how to make a frequency distribution and a histogram for a data set like the one that you see on the screen in front of you right now. We're going to be using problem number 32 as our example, and the title of that is Volume of Altria Group Stock. Now, before we totally launch on this, let's take a quick look at the calculator, a few points about fielding data-driven problems like this one. For a data-driven problem like the one that we just showed on the screen, you're going to be using some features of your calculator to key in that data. And so you're going to go to the Stat menu here like this, and you want to use the first command there, the Edit command, to take a look and see what you have here. Now you can see I have some artifact data in my lists, and we don't want any artifact data contaminating what we're doing now. And if you don't look, there's no way to know. So generally speaking, the first thing I would want to do with any data-driven problem is I would want to clear my lists. And you can do that a couple of different ways. You can go up to the top of a list like this, and you can press clear and then press enter, and that clears them on an individual basis. Or you can also clear them all at once. And so if you want to see that, you go out of here. You go back to the Stat menu, and you'll notice number 4 here, the Clear List command. And then down here over the number 1 key, you see L sub 1, and then L sub 2, and L sub 3, and so on. Those are the names of the lists. And so if you want to use that command right there, what you do is you press enter, and then you have to tell it what lists you want to clear. So list 1, comma, list 2, comma, list 3, and so on. And that wipes the list, as you can see. Now sometimes it happens that you are using a rented calculator, and it's not uncommon that people will accidentally delete the lists, and they don't always know how to restore them. And since many of the functions that we use are going to default to list 1 and list 2 as an example, it's really inconvenient if you don't have those lists in the calculator. And so typically what happens is somebody inadvertently goes up and they hit the delete key, not meaning to, but you'll notice now that list 3 is gone, or list 1 is gone. And so if you want to restore these, the best way is as follows. You can quit this, you go back to the Stat menu, and number 5, the Setup Editor. This command will restore all the missing lists. And so if you press enter and you press enter again, it runs. And then if you go back and you look, you'll notice that all those missing, accidentally deleted lists have been restored. So that's something good to keep in mind if you're using a rented calculator. Now for this particular problem, we're going to need to key in some data. And so we're going to go back and take a look at that. And what I would invite you to do is, if you'd like to follow along with your own calculator, that might be really good. So when we go to the data set, if you like, you can pause the video, or if you have your textbook handy, you can just copy the data directly from your textbook, whatever works for you. So the problem says Altria Group Stock. The volume of a stock is the number of shares traded on a given day. The following data in millions, so that 6.42 represents 6,420,000 shares traded, represent the volume of Altria Group stock traded for a random sample of 35 trading days in 2014. So we need to get this keyed in, and even though the table is separated into multiple rows, the entire table is going to be entered into a single list. So I'll go back to the calculator and do that. You go to the Stat menu, and you need to use the Edit function. So you can see it's already highlighted. Just press enter to select it. And now you can start keying in the data. And so on. Let me accelerate this process. Always a good call after you've keyed in some data like this to make sure that you've gotten everything. Without going through the list carefully, I can see that I have entered actually 35 data values, because as you can see on the screen, the calculator is waiting for the 36th data value. And so that tells me that I've got 35 in there, which is how many are in the table. So at least I got 35 keyed in. If they're not perfectly keyed in, well, we'll find out, but I think that I have them keyed in accurately. Let's go back and look at the problem. Now the full instructions aren't visible for this range of problems here, but the idea is they want you to make a frequency distribution and a histogram. And so part A of the question is saying, if 6 classes are to be formed, choose an appropriate lower class limit for the first class and a class width. Let's talk about that for a minute. Now in truth, if you were making a histogram and a frequency distribution for some actual data, say as part of a job or part of a project, something like that, you'd probably be using software to help you with that. And unfortunately, in our class, we have a graphing calculator. And so there are some workarounds that we employ for that reason, because the graphing calculator doesn't quite do everything we want it to do. And so in particular, if you're using software like SPSS or Minitab or SAS or something like that, that software takes a lot of the thinking out of the process, and it just generates what you need. We don't have that, so we have to sort of figure out a few things on our own. So in particular, when you're making a frequency distribution, the first thing you have to figure out is the class width. And so as you can read here on the slide, we're saying that there's no right or wrong answer for this. There are many correct answers, actually. But you can choose a good one if you think carefully. And usually the way we would think carefully is we take the largest data value and we subtract the smallest data value, and then we divide that by the desired number of classes that we're being asked to use. And we're going to then carefully round that value to figure out what is going to be best for a particular situation. So in this case, here's what I would recommend. When the data is all jumbled up, as you can see on the screen here, it's much harder to find the smallest and the largest data values. It's much easier to let the calculator help with that. So I'm going to quit this, and I'm going to go back to the stat menu, and I'm going to use one of these two functions right here, either sort A or sort D, which stands for sort ascending or sort descending. It really doesn't matter which one. I'll just go with number 2. So you select that function, and then you have to tell it the name of the list where your data is hiding. So in this case, we're using list 1. And so now if you go back and take a look, you'll notice that those data values have been sorted. And already the smallest data value is visible there. It's going to be 6.37. And so if you want to see the largest data value, the easiest way is just to go up, and then you'll notice that the largest data value is 23.59. And so if you can remember those two numbers, you can then figure out what your class width is going to be. Let's showcase what we're going to do. So as we were saying, we want to come up with a number for class width, and what we do is we're going to take the largest data value minus the smallest data value, and we're going to divide by the number of classes that we're supposed to have. So in this case, the largest data value is 23.59, the smallest is 6.37, and the problem was saying that we're supposed to come up with 6 classes. So let's get this number and calculate it. I'll open up a parenthesis. I'll take 23.59 minus 6.37, and I'm going to divide that by 6. And so there's my result, 2.87. Now I suppose if you insist, you could use 2.87 as a class width, but it's going to be inconvenient. And so what we're looking for here is a path of least resistance, because we don't have software that's going to do it for us. So we're trying to find the easiest way to come up with the required frequency distribution. And for that reason, I think I'm going to round this up. And I'm thinking that 3 is probably a good choice, but we want to verify that that's the case. So let's go back and take a look at something here. We were saying here that when you put everything down on paper, that your classes, your bins, have to be mutually exclusive. That means that they can't overlap. It has to be clear to someone who's putting data into these bins or these classes which one something goes into. And so if there's any overlap, then it's ambiguous, and we don't want that. So they can't overlap, and we have to have the class width uniform. So in other words, all the classes, all the bins have to have the same width. And we'll talk a little bit about calculating that width in a minute, but the bottom line is that when you put all this together, you have a certain amount of license. You get to choose right? And so we want you to choose wisely. So if we're going to go with a class width of 3, let's see what else the problem is asking. The problem says, if 6 classes are to be formed, choose an appropriate lower class limit for the first class and a class width. So we did that kind of backwards. We chose the class width first, which, to be direct, you have to do. And so now we want to figure out what are we going to use for our lower class limit for the first class. So in other words, is it going to be 6.37 or is it going to be some other value? And there's a few things to keep in mind here as we do this. When you make a frequency distribution or a histogram, sometimes it happens that you'd have an empty class or an empty bin somewhere in the middle of the distribution. And that's perfectly fine. It happens sometimes. What can you do? But we cannot accept empty bins or empty classes at the beginning or the end of the distribution. So in other words, if you're writing a frequency distribution, it would be at the top or the bottom, because we normally write these in a row fashion. Each row represents a class. And if we're doing a histogram, then it would be a graph. And for our class, normally the histograms have the classes on the x-axis, the horizontal axis. And so in that case, the empty classes would pop up at the end, meaning the left end or the right end. And so we're saying that's not good. You can't have that. If you have something in the middle, that's okay. But if you have something at the end, at either end, that shows that your classification scheme wasn't well thought out. And so we don't want that. So if we go back to look at what we have data-wise here, what I was saying before is that we could use 6.37 as the lower limit of our first class, or we could use some other value. And what I would suggest is that some other value is more convenient. Decimals are always a hassle, and so I think I'd like to avoid having to do too much calculating as I assemble this. I just want to have it easy. I want to be able to figure out everything directly without going to the calculator. So I think I'm going to go with a lower class limit of 6 and a class width of 3. And so that means that the very next thing I want to do is I want to check, I want to look before I leap to make sure that my classification scheme is going to capture everything. And so how are we going to do that? Let's take a quick peek at the calculator. What I would normally do is I want to calculate what is effectively the upper limit of my last class. And so, in other words, I want to make sure that that value is larger than my largest data value. Because if it is, I'm going to capture everything, and I'm not going to have any empty classes where I don't want them. So we were saying, let's use a lower class limit of 6, and we're going to use a class width of 3, and we were saying we wanted to, how many classes? There were 6 classes, right? And so if you'll notice, that gets me up to 24. And my largest data value was 23.59. So I think I'm okay here. I think that classification scheme is going to work. So let's put down on paper what it is that they are asking in this particular part here. So I'm going to go with a class width of 3, and the lower limit of my first class is going to be 6. Now, something to keep in mind about class width. It's a common misconception that when you're calculating the width of a class, you take the upper limit minus the lower limit, and that is not correct. When you calculate class width, you're supposed to take consecutive lower limits and difference them, or consecutive upper limits and difference them. And so, in other words, if I'm going to put down my frequency distribution on paper, here's what it's going to look like. Again, I'm supposed to have 6 classes. And so my lower class, my first class, has a lower limit of 6. And then 6 plus 3 would be 9. And actually, it's probably not a bad idea. If you notice, the data values that we were looking at have 2 places. And so even though it's kind of obvious that 6 is the same as 6.00, most people would probably be a little bit more comfortable if you represented it in that way. So maybe we should do that. And then 9 plus 3 would be 12. 12 plus 3 would be 15. 15 plus 3 would be 18. And 18 plus 3 would be 21. And so those are the lower limits of the 6 classes that I'm going to be using. Now, as far as the upper limits are concerned, and by the way, notice if you take 21 minus 18, you get 3. 18 minus 15 is 3. 15 minus 12 is 3, and so on, right? That's how you calculate class width. So now I want to put the upper limits in place. And in this case, because the data values have 2 places, we want to make sure that our class limits, especially the upper ones, have 2 places so that it's clear where a particular data value goes. So in other words, imagine if you had a data value of 8.99, which class would that go in? Would it go in the first class or would it go in the second class? And the answer here is apparent. It goes in the first class. And so on. So those are our class limits there. Let's finish that off. So now I have my classification scheme established, and one bit of advice regarding the very last class limit, the 23.99. That's the upper limit of the last class. Sometimes people stumble on that, and it's easy if you just consider what would be the next class. So obviously it would start at 24, and so you're going to be rounding just before 24. So 23.99. Anyway, let's do what we need to do on the calculator. Now regarding what's next, if you actually read the problem, it's asking us to flesh out this frequency distribution here. And you can do it by hand if you want, but it's a bit tedious. And unfortunately, the calculator does not cough up a frequency distribution directly. So we have to use a workaround. And so I want to show you what that workaround would look like. My calculator will produce a histogram. And if you understand, a histogram is just a visual of a frequency distribution. So in other words, it's 2 different ways of saying the same thing. And so all I need to do is to get my calculator to produce the histogram that I need, and then I'm pretty much home free. So let's see how to go about that. I'm going to go up here and turn on a stat plot. And you need to have one of them turned on. You can see that I already have one turned on. So you can just press enter to select it. And you want to select the type. So the one that's flashing right now is the one that we want. That's a histogram. And you can see that it's asking me, where's the data? That's the X list that you can see there. Well, if you recall, our data was in list 1. And so now that I have everything set, I'm ready to go. And if you want, you can change the color if you have that capability, whatever. But I don't really care. Anyway, I need to get out of here. And I want to graph that histogram. And so the easiest way to get it on the window with the proper window size, or with a reasonable window size, let's say, is to go zoom, and then number 9, if you'll notice, is zoom stat. And so you can select that just by pressing 9. And so it gives me a histogram here. And it gave me something else too. It looks like I have a function that I was graphing in there. Let me dump that. Okay. So I'm almost there. I just need to make my window size work better for me. So if you want to see what we have currently, you can go and press the window key here. And so you can see that the minimum value, in other words, the leftmost boundary of the window, is 6.37. Now that shouldn't be a shock because we know this value. It's one of the data values. So the calculator selected that, but we were going with 6. And as far as a maximum value, you don't need to put that in. But if you want, you might remember we calculated and showed it was 24. And so no harm in putting that in. This value right here has a different function. If you've graphed stuff using a graphing calculator before, you probably think that x scale, which is this particular thing here, is the distance between the hash marks on the x-axis. And normally you'd be correct. But when you're graphing a histogram like this, it's the bin width or the class width. And so we want to set this as 3. And then for the y minimum and the y maximum, you can probably leave those intact. But you might want to give yourself a little bit of breathing room just to be on the safe side. So I'm just going to make them a little bit different than they were. And then the y scale and the x-res and all that stuff is fine. You don't need to worry about that. So you can just press graph. And now you have a histogram. And at first it may not seem like that's helpful until you hit trace And you realize that as you pass through this, that it's telling you the frequencies for each of the classes that you just set up. And so what we would want to do is to transfer this to our paper. So the first class, as you can see here, it has a minimum of 6. That's the lower limit. And it's less than 9. So in other words, it goes up to 8.99, as we said. And it has 15 values in it. And the next class has 9, and then 4, and then 4, and then 2, and then 1. And so all you have to do is write down the values of n in the appropriate class, and you have your raw frequency distribution. So let's do that. And so I have transferred those, as you can see here. And that is the answer to part B. Let's go back and take a look at the problem here. So we answered part A. Again, we used 6 classes, and we made the lower limit of the first class 6, and we chose a class width of 3. And then for part B, we constructed a frequency distribution, or what we would probably describe as a raw frequency distribution, as you saw. And so the next thing we want to do is the relative frequency distribution. Now, really the only difference between a raw frequency distribution and a relative one is the raw has the raw counts in each of the categories or each of the classes. The relative records the proportion of the data values in each class. And so I'm not going to put a lot of detail on this, but I'll show you how we get the values. So the first value is going to be 15 divided by 35. If you recall, there were a total of 35 data values. And so if you're calculating the proportion of data values in each class, you take the frequency and you divide by the total. So 15 divided by 35, and you just get that on the calculator. So you can quit this and then just do 15 divided by 35. And so as you can see, I'm not going to record that to so many places. I think in a case like this, probably 3 places would be sufficient. So I would probably render that as 0.429. And so then I'm going to obtain the other ones in the same fashion, but I don't think I'm going to write down the ratio. I'm just going to calculate the decimal values, as you can see. And I would say in this case, rounding to 3 places is acceptable. And if you add up those relative frequencies, you should get 1 or very close to it. Sometimes it's off by just a scooch because of the round-off error, but what can you do? So anyway, that would be the answer to part C right there. As you can see, part C said construct a relative frequency distribution. And we already showed you the answer to part D. We had it on the screen, so that was on the calculator screen. And then as far as part E is concerned, well, really it's just a rescaled version of of D. So in other words, if you were labeling part D carefully and you were drawing it by hand, you have a certain height for those, which is the frequency of each class. And if you were to redo that for part E, instead of the frequency for each class, you would use the relative frequency for each class. But the appearance would otherwise be unchanged. And then regarding part F, they're asking you to describe the shape of the distribution. And they're expecting that you know how to translate that. So let me show you something real briefly. When they ask you to describe the shape of a distribution in this part of the text, what they're really asking is which of these 4 histograms best resembles the set of data that you just looked at. And so in the case of this one, you can look at the calculator again if you want to see it. All you have to do is press graph, and the graph comes back. And I would say, well, you notice how this one has kind of a tail that goes off to the right. And so when you go back and you compare it with what you see in the book there, I would say that this distribution is skewed right, because it has that tail that kind of runs off to the right, just as you see in that figure right there, letter C. So I hope that's been helpful. And if you're asked to do a similar type of question, this is how we would expect you would go about it. And when you look at this type of a question in MyLab and Mastering, you'll see that the stuff that you have to key in is pretty much what we wrote down. And if they ask you, like for example, to come up with a histogram, normally they do that as a multiple choice. So the presumption is that you would generate your own histogram on your calculator, and then you would do as we're doing. You'd look and see which one best matches. Now there's one other thing which is not explicitly asked for in this problem, but it does come up, and sometimes it gets asked for, and so figure, hey, might as well throw this in kind of as a freebie. So one of the things we're going to want you to differentiate between in this course is a regular frequency distribution and a cumulative frequency distribution. And so as you can see here, I've put my table onto a fresh sheet. I kind of spread things out a little bit to make it more readable. And so when you do a cumulative frequency distribution, you're just taking a running tally, if you will, of what's been in the previous classes. So for example, for this one here, for the raw frequencies, the first class of the cumulative frequency distribution, there's nothing that comes before it, so it's just 15. But for the second class, it's going to be 15 plus 9, which would be 24. And then it's 24 plus 4, which would be 28. And 32. And 34. And finally 35. Now you can do the same thing with the relative frequencies, although obviously you're going to be using a calculator for that. So for the first class, it would be 0.429. And then for the next class, you're going to add 0.257 to that, and so you get 0.686. And then for the next class, you can just add the next value, which was 0.114. And so on. And so as you can see, I just have to transfer those values to my paper. And so now I have my relative frequency distribution and the two others that were not asked for, the cumulative raw frequency distribution and the cumulative relative frequency distribution. So if you are coming across questions where that's asked for, that's how you go about getting it. I hope this has been of help, and if you have any questions, feel free to drop me a line. Otherwise, please feel free to go on to the next video.